Hello, Matt Davis here with more homework quiz help. This one is from section 8.4. Suppose that the standard deviation for the heights of mature male giraffes is known to be sigma equals 0.703 feet. What sample size would be required to produce a 95% confidence interval for the mean height of mature male giraffes with a margin of error of at most 0.25 feet? Enter your answer as a whole number. All right, so first, in the interest of giving help rather than answers, we're going to change a couple things. So instead of 95%, we're going to change that to 99%. And then the other change is instead of a margin of error of 0.25 feet, we're going to make that 0.20 feet. Other than that, we'll be doing the same work, just with some different numbers. All right, so let's go ahead and start out with figuring out what our setting is. So they want us to figure out a sample size. So what sample size is required? So we're going to go looking for a formula that says n equals. And then we want to know whether we're in mean land or proportion land. And it says a confidence interval for the mean height is the setting that we're in. So we're going to go look at our formula sheet for something that helps us find the sample size n for a confidence interval about the mean. So switching over to the formula sheet, we're in chapter 8 when we're doing confidence intervals. This row right here gives us formulas about the mean. The one down here is for proportions. So we want the one for mean. And then here's an n equals formula. Here's another one. So we need to decide which one to use. And it's all about the type of standard deviation that you're given. If you have the sample standard deviation S, then you would use this one. But if you have the population standard deviation sigma or a guess at it, you would use this one. And in the problem we just read, they gave us the population standard deviation sigma, which is the best possible guess at sigma you could ever have is the real thing. So this is the formula that we're going to use. So we'll go back and write that down. Okay, so starting off writing down that formula, we have n equals, they have brackets, and then it's z star times sigma guess over the margin of error that they want, and all of that is inside of brackets and squared. So we just need to start gathering all those pieces for the sigma g. Like I said before, the best guess you could ever have at sigma is the real thing. And that was given to us as 0.703. So that's what we'll use for the sigma g. And then margin of error was also given. They want it to be 0.20 feet. So we know this, we know this, and the piece we still need is z star. And to get z star, you need to use your confidence level of 99%. So we will do that down below. So we'll draw a quick bell-shaped curve. We want confidence level of 99%, so we'll show that in the middle in decimal form, 0.99. That leaves 1% left over. We cut that 1% in half and put half on each side, so 0.005. Just as a reminder to check your work, always add these three numbers together. Make sure that they are totaling up to 1. If not, you may have forgot to cut the leftover in half, or you may have a decimal place error. Either of those would mess up your z-score, so you definitely want to double check that. And then this will be our z-star, this right-hand boundary, and that's the z-score with area 0.05 to its right. So z-star is equal to z sub 0.005. And that's a number we can look up on our t-table. So let's jump back to the formula sheet and grab that. So if we go to our t-table, since we want z of 0.005, we'll look at the column for t of 0.005. But all these that I'm highlighting right now, they're all t-scores. Everything in that table is a t-score until you get to this line at the bottom that's broken off separate. Those are all z-scores. So the one you want is in the same column as the t of 0.005. That's your z of 0.005. So 2.576 is the z-score that we want. So let's jump back and start working with that. So this z-score is 2.576. And now we've gathered together all the information that we need, so let's jump back up to the formula and start plugging that in. For the z, we have 2.576. For the sigma guess, we're going to use the real sigma, which is 0.703. And for the desired margin of error, they want 0.20. And then all of that is going to be squared. And that square is something that people forget to do sometimes. They forget to write it down. They forget to put it in the calculator, so be careful with that. So speaking of the calculator, let's head there now because we have all the information we need. So we will enter that in. So make sure you start out with those open parentheses. The formula on the formula sheet uses brackets, but it doesn't matter whether you use brackets or parentheses. So easier to just use the parentheses. And then times 0.703 for our standard deviation divided by 0.20. So put parentheses around the whole thing and then square it all. So we get 81.9865. Let's go ahead and write that down. .9865. All right, and then we always round n up. So our n here would be 82. And that's going to be the final answer that we put into active learning. So spots to watch out for, like I mentioned already, make sure you remember to do the square. Make sure you get these brackets or parentheses in the calculator so that everything is being squared. Make sure that your three areas on your normal curve add up to 1 so that you know you remember to split the leftover area and that you have your decimal in the right spot. And in this case, rounding up is natural, but if this had been 81.28, we still would have rounded up. You always round your sample size up when you're calculating sample size to get a certain margin of error. That's to ensure that you never get a sample size that's too low. Hopefully whatever gave you trouble has been fixed up here, so good luck as you head back to the quiz.